I am using human stem cells to grow three-dimensional chunks of tissue called organoids or mini brains to study when does schizophrenia really develop, when does it begin. Schizophrenia occurs in about 1% of the population, which might not sound like a lot, but in the United States, where you have a population of about 350 million, that equates to about 3 million schizophrenia cases. Unfortunately, some studies have estimated that as little as 40% of patients respond favorably to their first drug treatment if they're suffering from psychosis and schizophrenia, which is pretty appalling. The answer for why we don't understand complex disorders like schizophrenia and autism is that we can't take the brain out of a patient. It's not ethically possible, it's not technically possible. The hope of my work with schizophrenia and growing cerebral organoids or the mini brains is to evolve the current treatments into the next generation of targets so that we have medications that will work the first time, that will provide therapeutic relief to patients quicker, with fewer side effects, and really restore their quality of life.
If somebody is ill with schizophrenia, particularly in the first decade of the illness, the biggest challenge is keeping hope alive. The biggest challenge is keeping hope alive because there's so much coming at you.
During my first psychosis, I became obsessed with music. I would think that it is sending me some kind of message. I started to hallucinate little. I started to hear little voices, and I actually went into other people's house, and I would be like singing and screaming. So that person called police officer, and they basically treat me like I'm a criminal. You know, if I don't answer the question correctly, they give me that glance, and they would, tell me to turn around, do the search.
Everybody is affected. Every family is affected by mental illness. Not people on the street. I'm talking about your relatives, your friends, your coworkers. Why is it that we know so little? Part of the answer is just how mystifying the brain is. All the pieces of the brain react with one another through circuits. And these circuits are driven by these trillions of connections. So we're trying to unbundle the complexity of trillions of connections in a way to find a needle in a haystack.
The technology holds potential in not just answering questions, long-standing questions in the field, like, oh, when does schizophrenia begin, in an abstracted kind of way. They hold potential by identifying, well, this specifically happens at this time point, and if we target this molecule, this biological pathway, that has therapeutic potential in this human tissue. So what we're looking at here is an organoid that's been cut into a very small slice. The green dots here are neural stem cells, the blue dots are cells. But we see a thick organized band of neural stem cells that line the ventricular zone. That's what we're looking for. That is a hallmark feature of a developing brain. Once we grow our three-dimensional balls of stem cells called embryoid bodies, we move them down to the second incubator, and this is where we start growing them into organoids proper. We're growing hundreds, thousands of them at the moment. You want to promote nutrient diffusion. The organoids are chunks of tissue, but they don't have vasculature. They don't have a heart to pump nutrition into them to keep them alive. So to promote keeping them healthy, we shake them. So what we have here are organoids basically at 3 or 4 different points of development. The first one is when they are particularly small. It's about a week into the procedure, 1 to 2 weeks into it. So they're still growing, they're still choosing to want to become a mini brain. But as we maturate them and give them the food and nutrition and the environment to want to become a mini brain, they start to get progressively larger. These guys are already much larger, they're visible to the eye now, they're a couple millimeters across. If we give them 2 more weeks or so and let them advance to the next stage, they get even larger. And you can see we have hundreds of little mini brains in here that are noticeably larger than the last 2. And finally, in this last dish, we have one that we've been growing for quite a while, and you can see that It's rather large, about the size of your little, like almost a fingernail in a way. But the problem is there's no vasculature there. There's no heart pumping blood into them to keep them healthy at their core. So as these organoids are growing bigger and bigger and bigger and bigger, the inside is dying.
I'm still taking the medication that someone who is schizophrenic would take. I think it really depends on what doctor I've seen, and they all have their own opinions. I really don't know who to trust at this point because they've told me all different things. It's a little scary not to know what's really wrong with you. I would wind up sitting at home, curled up in the corner because I was afraid that someone would come and attack me. And they never did, but the fear was paralyzing. Before I started with that first medication, I was very uncontrollable, and the hallucinations were very overwhelming, and it was too much. But then it worked on an extremely high dose, and then it stopped working. And then we tried a bunch of other things that didn't work because they didn't really know what was wrong with me. And so then finally they found something that they thought worked, and then it stopped working again.
So what we're looking at here now then are two separate organoids. This is the same organoid and ventricular zone that I showed you previously. It was generated from a healthy adult. On the right, we have a patient-derived organoid. This is an organoid that was made from a schizophrenia patient. And there's something that's very obviously different between the two, and that is a lack of red. Through here is our cortical plate, or a developing cortical plate. This is the developing cerebral cortex in an organoid, and we're seeing a lack of neurons, which is in stark contrast to what we see over here in our healthy control organoid. Now, the easy thing here was identifying how schizophrenia organoids were different from healthy controls. The hard thing is taking something that's broken and fixing it.
To talk about the effect of schizophrenia, when you feel love, you get excited. But in my case, I was very afraid. I am still afraid of those emotional change. Like, I would always have to be aware that I might be manic, but not in love. Just because of that, because I get so anxious at some time, maybe I'm gonna have another psychosis. Then I would actually overdose my medication sometimes.
What we came to find was that we did identify molecular differences that were replicable. And if we reconstitute these molecular factors back into the schizophrenia mini brains, we could actually fix some of the things that were wrong with them. That's the promise and potential of the organoid technology.
I wish there could be a way that there wouldn't be so many side effects for the treatments. I wish there was more of a cure almost. I know there's not, but I wish.